Thank you, Nick. Appreciate it. Hi, everyone. My name is Karim, and I lead go-to-market for AMD's GPU business, working with AI startups. I see plenty of you guys in the audience, Midjourney, Higgsfield, and of course, Essential. My connection, wow, we were really far apart.
I know, right?
No, you're good.
Yeah.
They probably need it for like the video and stuff.
Plus also, I mean,
My connection to Essential AI goes back to the classroom, actually. I took a course at Stanford on transformers, and I had the privilege of learning from none other than the co-inventor of the transformer in Ashish Vaswani. So naturally, this is a full circle moment from academia to industry, and it's even more meaningful that we get to do it together on stage, even though we're so far apart.
we work closely. It's good to maintain a balance.
Let's start at the beginning. And the beginning for me is the invention of the transformer in 2017. At that time, it wasn't just the architecture that changed everything. What I've heard from you repeatedly is that it was the culture of open collaboration that made it possible. Can you take us back to that moment? What was the research environment like? How did openness shape the breakthrough?
Karim, pleasure to be here. And actually, our connection was established after the class at lunch, and when you drove me back from Palo Alto to the office, which was, wow, this is I think it's 2 years ago, and we were like maybe 4 or 5 people. So
yeah, that was
here
fun.
We are. It's exciting.
I don't know if my brother's in the audience, but it was his car. It was a 2007 Toyota Scion TC. I was very embarrassed.
My memory doesn't go to the make of the car, but it was an interesting discussion. But yes, so to your question, if I could use a word to describe, well, the environment, which I do consider important, it was electric, right? I mean, it was the early days, and boy, it's been close to a decade. One of the earlier days in deep learning. Incredibly, I mean, there were brilliant colleagues and doing great things, and I think it started with an irreverent idea. We wanted to do originally diffusion models for language, and yep, we were probably 8 years too early for that idea. There's been some exciting developments there, and self-attention was a really good mechanism for that. So after the initial sort of excursions in diffusion models or this iterative refinement models didn't quite work out, we said, okay, let's take what we learned, put it back to autoregressive architectures, and the team together we built something that we iterated through some versions of the architecture, and for me, personally, of course, the time was important, exciting. I learned a lot. It was a lot of joy to work on research that has been impactful. But since then, because we put it out in the open, right? It's like every year you see just more and more of the power unleashed of the architecture, of the model, and not just the model, but breakthroughs all around. And if we wouldn't have, I think, released it, I don't think we would have had so many advances since then. Or I don't know, maybe hard to say. Counterfactuals are hard to say if you wouldn't have been here or not. Yeah. But I think open research was an important component.
100%. I know I've heard from you repeatedly that it's paramount. And now, is that same level of openness available today at the frontier?
So I still think there are very many labs doing brilliant work. I think there's been one change since then. That is, it's startups also are also doing producing revolutionary ideas, or they're producing frontier models. So that's different. But I do think that the same level of open scientific exchange and collaboration has reduced. And if we had an idea like the transformer or ResNet that was, or I don't know, maybe even flash attention, for example, that were closed, I imagine that overall progress would be slower. Because open exchange of ideas significantly advances the state of the art, and that's what we need right now. Because if we believe that we're building, at least I personally believe that we're building the most important tool for humanity, that a tool that's going to be used to solve some of our most important problems, like building new jet engines or helping discover new drugs. I think that we need a pace of advancement that truly comes when things are truly open.
Absolutely, absolutely. I've heard you describe Essential AI as a factory for breakthroughs. And that's certainly been my experience in working with a brilliant team. I don't know if you want to give a shout out to your team members.
Yes, so we're all factory workers. There's Michael and Philip and
that's not what I meant.
I mean, that's what I meant, though, right? This is Divya Koi and Alok and Saad. So it's I represent all their brilliant work. And first and foremost, look. Open science is absolutely, it's important, it's vital, right? But for us, the primary desire is to do great work. We believe we can do great work. We're students of, students of AI, students of computation, and we believe, and we want to build, we want to push the capabilities of our models, and open is a strategic imperative. It's a means to getting there faster, because 10,000 brains can work on the same problem, right? But yes, I think that in order for us to produce great ideas, you need to have a factory for breakthroughs, and it's not about any single model. It's actually about the rate of progress. It's about refining your ability to do experiments or iterate on ideas that ultimately creates a great creates a fantastic research lab. Yeah.
Let's dive into those breakthroughs, right? So I think you're proving out that you can actually do reasoning and reflection in pre-training. So maybe speak to that and give us a glimpse of what else we can expect from your factory workers.
Yes. By the way, I hope they don't mind. I just referred to them as factory work. But and again, I want to say that an important part of doing science, doing good science is being honest about your ideas. So I know we are freely using the term breakthroughs, but I do think the work that we've done this year is fantastic. I love it. There's a divide in the community about post-training or reinforcement learning versus pre-training, and we had the intuition after. This was very close after DeepSeek came out that, we believe that most of the abilities are actually acquired during pre-training, and reinforcement learning is likely sort of amplifying what's already there. If you didn't have very good base models, you wouldn't see these dramatic improvements. So, and a really important ability is the ability to iterate on your thoughts. And not only did we discover it during pre-training, thanks to a lot of the open work that the Allen Institute did, we all stand on the shoulders of giants.
For sure.
And the models that they had released, we were able to discover that yes, this ability to iterate on your thinking is present, and it evolves as you pre-train. So, and then what that means for us is that ultimately, if you want to drink from the source of truth, then pre-training or training at scale is the right philosophy, is the right approach. So that's the approach that we are taking, right? With pre-training models, and soon after that we published a great paper on the new optimizer, and it's been a decade since there's been any fundamental advancements in neural network optimizers, and we showed that a new variant called muon achieves more better intelligence per token than Atom, and actually we did it on and in fact there was a lot of great infra work that we had to do on made it work well on the MI300X cluster. Yeah, I'm really excited about it.
Thank you.
Yeah.
I appreciate that. I was just going to ask what the role of AMD was in this journey, but we'll get to that. We have plenty of time to get to that. But maybe I think I want to do essentially justice by talking about the different tasks that these models enable, right? Like code generation, text, logic, what it might be. So can you walk through that and where you're the farthest ahead today?
Absolutely, and I forgot to mention that, but we're focusing on two domains. We want to build models that are frontier and software engineering and helping with scientific discovery, and these are the two areas we're focusing on. I expect, I am quite confident that by the end of the year we will have very, very strong open science coding models, and by next year push models that can actually aid with scientific discovery. We should have some more releases just coming down the pike as well. Hopefully you all will appreciate and contribute and follow or sort of add to our work. But yeah, we're focused on coding and building models that can aid with scientific discovery, and that drives a lot of the ideas and the research methods that we also want to experiment with.
Beautiful, beautiful. Okay, so let's get into the AMD part now, which
Finally,
we're
right, yeah.
eager to get into. Maybe we can break this out into training and inference. What's been your experience since getting up and running on the MI300X cluster?
So before I directly jump into the MI300X cluster, I want to say that I hope and I hope and wish that people give you and the AMD team who've been working tirelessly and very closely with us and with Philip, Yash, and the team, they give you credit for all the progress that you've made, that we've made together.
We're also a factory.
Yeah. Yes. Yeah. I mean, you truly have. You have fabs. Yeah. So, fab of the mind. So yeah, it's tough, right? And I'm both very impressed and proud of the work that we've done together. We've generated, I guess on the inference side, it was a much easier story. We've generated trillions of tokens, yes, trillions of tokens on our MI300X cluster. But personally for us, given that's so core to our mission, the work that we're most proud of is that we've made large-scale, training work on a large-scale MI300X cluster. The initial models are very, very good, and we're on to our second series as well. And it took work, but together, with taking great feedback, you all are very good at taking feedback, and with the brilliant team that we have here, we've been able to achieve great things together. So both inference and training, it's been a very exciting journey. So congratulations.
Thank you. I know the number one takeaway that we had from Advancing AI last year, it actually came from you, because I shared this with the team, and then it bubbled up to the top, and that was around, I had no idea that there were other builders that were building on top of MI300X. Like, I'm so grateful that I get to talk to other developers and customers, and I've been seeing you collaborate with some of our customers. There are other customers that I want to introduce you to that are here too. So thank you for that. That means a lot. And then the second biggest thing I have to share is that startups move incredibly fast. The feedback loop is so tight. We hear from them, and then what we do is we incorporate it back into not only making Essential happy, but we incorporate it back and make other customers happy, right? So we even have hyperscalers like Meta that are starting to do training, but they weren't there first. You helped us with that, right? You were our first customer for training for MI300X. So maybe if you can speak a little bit about training, that would be super helpful.
Not only there's of course MFUs and being able and having the flexibility to try out different architectural ideas like long context, which is very important. But it's also the ability to scale out and achieve very, very good scaling properties on a large cluster, and that's what we've been also very, very impressed with. And it's extremely important because as we experiment with larger models, mixtures of experts, we're confident that we will be able to achieve the next stage of the capabilities that we want to.
Awesome.
This is what we're already seeing.
Okay, so let's zoom out to close. You painted a bold vision where open science, powerful infrastructure and factories, and global collaboration come together. So if we do this right, if openness becomes a first principle again, what does the AI ecosystem look like 3 to 5 years from now?
Yes. So short answer. Short answer. It's difficult, but I'll give you my personal views here, right? I imagine a world where our models are open models. They're being used to prove new theorems. Like there's I think only one of the Millennium Problems has been proven, the Poincare conjecture. There's many others, and I don't know, Terence Tao using our models in the Polymath project to somebody wanting to talk to our models to have a conversation with Wittgenstein. I learned that one of our Pete, who's not here, actually studied philosophy and is undergrad at Oxford. Or people, wet labs using our models to design new drugs, but at the same time contributing back in terms of data or new environments where these models can actually learn from rewards. And I get excited. Of course,
I want to double click on that point, right? Because we also work in the healthcare life science space, working for a Gen AI drug discovery company, and it's incredible to see them shift from wet labs to Gen AI to discover new drugs. And it sounds like your platform is going to be an enabler for that.
I believe that's possible. I think, and also, I would, I mean, if I were being selfish, I would want all the important breakthroughs to come from Essential. But I think that an open world leads to truth faster. I think that's ultimately as important. And it's not impossible to imagine a world. We don't see it today, but DeepSeek came out and we are unable to stop talking about it, right? There'll be more results like this and from us as well. And I think I believe the script will change of how AI should evolve.
Awesome, awesome. Well, I think we went from classroom to cluster. We covered a lot of topics here. Any final thoughts before we turn it over to the audience? And maybe if we can queue up some microphones to go around.
Well, one, of course, excited about our partnership and where it's going to go, well, I guess I'll just
leave us with something inspirational, Ashish.
Inspirational. Well, okay. So even though for the last close to 8 years, I've seen every year these models, their capabilities improve. I think it's still very early. So because it's very early, there's just so much important work to do, and we're excited to do some of that work, and excited to also have. I guess is advancing AI together is the motto. So yeah, it's advancing AI together. I was cheesy, but I hope it's inspirational as well. Yeah.
Absolutely. Thank you so much. Really appreciate it. Give a hand for Ashish Vaswani.
Yeah, hi.
Thank you,
Hello.
Rebecca.
Yeah, I was wondering, what role do you see a scientist play in the future? Let's say physics, chemistry. What's your ideal workflow, let's say 5 years from now?
Well, I'm only going to be positive about this because because at least, I was trained as a scientist. So the most important role. No, what role do science, I think scientists should be immediate collaborators with these models. I refer to them as tools, right? I think that they should play a very important role in the process of scientific discovery. I would hope that I think we should think of a world where we can bring back, at least if you're building open models, we can bring back some data or knowledge that we acquired in interacting with these models back, so that the overall capabilities can improve. But optimistically, I do expect important discoveries to be without computation. I don't think I think as of today, without computation, we are unable to make discoveries, right? LHC to astronomical discoveries to protein folding as well. So we've already had a relationship with computational tools. I now believe that we'll have maybe relationships with apprentices or collaborators that can help us, discover even more. But I hope that this will not be siloed as much selfishly, so that data comes out, some form of these interactions come back, and the models, the capabilities improve, so that we can solve even harder problems. Yeah.
So it's really cool to learn how you guys initially worked on diffusion-based approaches for language modeling. Do you think, given the recent advances, it's worth revisiting that direction for you guys?
So I do think so. So I like to think that gradient descent is smarter than me, right? Ultimately, so all I'm really trying to do is just create the settings for gradient descent to thrive. I do. I'm not, for instance, I'm not even sure if I'm very excited about these kinds of thinking models or chain of thought models, maybe everything should happen, all the search should happen in continuous space, right? And diffusion models offer that nice, attractive property. They can, right? So by that virtue, yes, I think they're, but I feel like the simplicity of autoregressive models is so compelling. So maybe the bridge might still be continue pushing autoregressive models, but use them as maybe a means for generating data or a guide for ultimately diffusion models to prosper. But so I don't think I gave you really an answer. I think this notion of iterative refinement is very interesting, especially in depth, the way they do it. I think it is very interesting. Yeah, that's what I have to say. Yeah.
We've got time for a couple more questions.
Hello. Let me take you back a little bit. When early AI like ELIZA and Shurlu came out, there was a lot of hype on, oh, the computer is thinking like a human. And after a couple of years, people said, oh, it's not really thinking, just mimicking how we think. And developers will say, duh. Now, there is another paper that says AI doesn't think; it only mimics what we think that this is thinking, and developers will say, "Duh." But one thing is true: models and AI are only as good as the people that trains them, the model, the data that they ingest. How do we share outside the people that doesn't know the implementation, that bias, that false data, they're still present, and we need to guardrail against that, especially with so many models going there?
Yes. So I'm going to. You made a lot of interesting points in your question. The one I'm going to focus on is how do we make sure people understand what they're using and have the right guardrails. One of the biggest reservations against open models has been that they could be unsafe, but I actually think it's the opposite. They would lead for, the more people expose and remedy the vulnerabilities, the faster we can actually get to safer models. So I think the open approach is aligned with that intention and motivation. Well, maybe I'll go to another point in your question about models mimicking humans. I think that I think I know what paper you're talking about, and there was a much more thorough treatment. There was a much more thorough analysis of the findings in that paper. My first observation was, even when I read it, I was thinking, well, people should actually be amazed at what these models can already do. Nothing could do it, and the models couldn't even do remotely these kinds of tasks even like 2 years ago, maybe. So. I don't think I think being able to successfully mimic how we think is a very desirable property. I like how I think sometimes, and if a model is able to mimic how I thought, I think we would do something. We would probably be able to discover new knowledge. Yeah, I think mimicking how we think is not a bad idea, generally speaking. Yeah. Although I don't know if they do or not. I don't know if they do or not mimic how we think. Yeah.
Sorry about that. The mimic thing was like the model are mimic us, and us, we are the problem, right?
Oh.
If you are mimicking a very bad person, you get a very bad model.
Well, so clearly that's not a question that I'm in a position to answer. Yeah.
But about the closed model.
I understand.
Companies.
Right.
Yeah. Thank you.
Sorry, I have a question about transformer architecture. So in your opinion, what would be the top 2 to 3 use cases where transformer architecture is an overkill? For example, some time series like audio models where you can use state space models that are cheaper and faster, or latent space parameterizations, or some other better data generation approximation through like more parameterized way or semi-parameterized way. What are some of the use cases you feel transformers are overkill?
So I guess I haven't quite followed the literature, but I get the impression that time series have resisted transformers quite a bit. I don't see any fundamental limitation. I think if we, I think we could successfully model time series. But maybe the question is, we're trying to build architectures in general under certain constraints. I mean, one of the biggest constraints is physics, which is the accelerators that we're training these models on. And if you can reduce most things to matrix multiplications, you have something very efficient. And also, I guess, gradient descent is an automatic method to learning, is a means to learning programs automatically. And it should, and I think that, so there's a few constraints. Architectures typically need to make a few of these, satisfy a few of these constraints, and I think the transformer generally does a good job of that. Me personally, I don't. You made good points about latency, and those considerations are important also when you think about longer contexts. But a lot of my thinking, it goes into less the architecture actually, but what are we training it on? So I hope that as we train on data that we see on the internet, we will also learn the latent processes that generated the data. I believe that is the ultimate, that is the platonic ideal, and I don't fully know if we do or not, and what are the ways in which we can. So that's a problem that's particularly exciting to me. And for that idea, I think that insofar as I can think, the transformer is a reasonable architecture, right? But what are the new methods for learning, the paradigms for learning, that is more interesting. And then maybe the era of architectures will arrive again and we will have to discover new architectures. But your point about efficiency, yes, I mean, there are certain, when you add some more constraints, then yeah, you're right. Indeed, the transformer is not the most efficient, and you need to distill it into, say, a state space model. But most of my time is spent on, I think, of different other directions. Yeah.
Thank you for that question. We're at time, but lucky for us, we've got Ashish's time for the rest of the afternoon.
Is that right? No, I'm not. I'm leaving stage right. Oh, you mean?
No, we're not going to keep you hostage here. But he's here until 5 p.m. So feel free to ask him questions. Feel free to ask the team behind the factory for breakthroughs.
They know all the answers, by the way. Just, yeah.
But yeah, thank you so much. Appreciate it. Rubin, are we exiting this way? Yeah. Thank you. Thanks Ashish.